Welcome back. I have Selena here with me, and we are going to work on a special lesson that's more like a challenge or like something extra, because this one is a little bit tricky. So you've had a lesson on transforming a square algebraically. You've had a lesson on transforming a square into a trinomial. And so now we're going to combine those two lessons. So when we did the algebraic lesson, we did it with a binomial, and that was not too hard. We had A's and B's, and we looked at different characteristics of that. So today, though, we're going to transform a square into a trinomial and look at its parts. Last time when we talked about this, we talked about how we have another material on the shelf that is a binomial. We don't have to transform it into a binomial, and that is our binomial cube. And so our binomial cube, if we were looking at this, we could look at this and say that this length is A. So this is an A square, and this length is B, making this the B square. And if that's the case, then this one here is B times A, which we would call AB. Yeah. And then this one here would be A times B, which we would call AB. And so we can think about the binomial cube algebraically. Now, when I said we're going to convert our square into a trinomial, and I connected to the binomial cube, we can look at this one here. And so just like when we're looking at this, the lid or the parts, it was not in there the way, there we go. Just like when we're looking at our square that we're working on and we're looking at the trinomial cube, we're going to have parts. Now think about this. The binomial had two names, A and B. The trinomial, how many names is it going to have? Three. And so we still have our A and we still have our B, but look at what we have down here. C. We're going to call it C. You can actually use any letter you want to replace a number in algebra. They're called variables when you change them to a letter. We're going to call it A, B, and C, A, B, and C for this lesson, but we could do just as easily do G, H, I, or K, B, F, KFC. We could choose any letters we want. We're going to go with A, B, and C today. Okay. What? Okay. Oh, I only got enough. I didn't get enough hair ponies for this. Will you pull off two more purples, please? Purple. So we're transforming our 10 square into a trinomial. 1, 2. It looks scary. Does it look scary because it has lots of parts? Yes. Okay. So I tried to make it similar pattern to what you could see here. Okay. So we have a lot of parts to label. So we're just gonna get started labeling our parts here. We're gonna label them first the way they would be on the trinomial, and then we'll flip them over and label them with their algebraic terms. Okay, so up here in the top corner, what do we have? A squared. Well, we're gonna label it. We're gonna label it with its number first. 5 squared. The 5 square. Mm-hmm. The 5 square. So in this example, our A is gonna equal 5. Okay, let's look at what this over here is. It's 1, 2, 3 times 5. 3 times 5. I'm going to leave us in this view while we're making the labels, but then when we change them algebraically, I'm going to switch to the other view so you can see closer up. I'm going to put it there. Okay, what is this one here? 2 times 5. 2 times 5. Okay, now we're right here. We have 3 and 5. 5 times 3. And what is this? It's 3 times 3. It's our 3 square. Yes. 3 square. And then what's there next to the 3 square? 2 times 3. 2 times 3. I'm going to move the 3 square off to the side. You know that it belongs right there in the middle. Okay, now we're on the bottom row. 1, 2, 3, 4, 5 times 2. 5 times 2. And then what's the second one?
3 times 2.
And right here on the bottom?
2 squared.
The 2 square. Okay. So I already told you that we would call this first one A. So A is going to be the 5. And then this will be our B, which is a 3. And our C is going to be a 2. I'm going to make a little cheat sheet so we always remember that. A equals 5, B equals 3, and C equals 2. Sometimes it helps to do that just so that you don't forget what you're working on. Okay. 5 squared. If A equals 5, then this now becomes the A square. I am going to change the view. It's going to be the A square. This becomes the A square. Now we have 3 times 5. 3 times 5. A 3 is a B and 5 is a A. So we're going to call it AB. Remember, algebra, we use the alphabetic. Here we have a 2 times a 5. What's a 2?
C.
And 5 is a
A.
So this is an AC. It's an A and a C alphabetically. Okay, a 5 times a 3. 5 times a 3.
AB.
AB. And now we have 3 square. The 3 squared. B squared. And we have a 2 times a 3. 2 times 3.
B.
2 times a 3.
BC.
BC, because it's alphabetically. Okay, 5 times a 2. 5 times a 2.
C.
Okay, and a 3 times a 2.
BC.
3 times a 2, BC. And a
C
2 squared. C squared. All right. Now, as we bring these down, I want to look for things that are the same. I have 1A squared, and I'm going to add it to, what do we see? I see the next one's an AB. Do I have another AB?
We have 2 AB.
2 ABs. So I'm going to pull this one aside and make this a 2. Plus 2AB. Now, here's an AC. Do I have another AC?
2.
Ooh, okay. We're going to put a 2 and pull the second one out. 2AC plus,
BC.
well, next is our B
Oh,
squared.
B squared. Can't forget B squared.
Yep, and then now we're at BC.
Oh, we need our plus sign.
Here's another plus sign. We need, in a trinomial, we need more plus signs.
And we have 2 BCs, so we can take one away.
2 BC. I wrote that one really weird.
It's fine.
It's special. Okay, plus
C squared.
plus C squared. Look at that.
Numbers.
It is a lot of numbers, but remember a trinomial was 9.
Yeah.
So we have less than 9
True.
because we doubled them up. Okay, so I'm going to point to them as we talk about them. We have the A squared, which is the square of A, the square of 5. And we have 2 ABs. AB is anything that is 5 and 3. So 5 times 3 right here and 5 times 3 right here. These are the same. They have the same value. Do you see how they're the same shape? Mm-hmm. And then we had 2 AC. AC is 5 times 2, and I have one rectangle that's the same here and one that's the same right here. Mm-hmm. Then we've already done this whole column and this whole row. We've done everything there. We've done everything there. Then we have B squared, which is our 3 times 3. Mm-hmm. And then we have 2 BC. BC is this 3 times 2 right here. And those are exactly the same. So now we've done everything to there. And all that's left
is the C squared.
Is the tiny little C squared. So it does look like a lot, but then when you think about it, you think, oh, there's 3 that are all unique, and there's 2 of each of the others. And maybe you've noticed that when you've built the trinomial cube. Maybe you have noticed that the that there's pieces that are different shape that you look at and you're like, oh yeah, look at all those pieces that they're the same. I'm gonna slide this over out of the way and we'll just explore that really quickly. I don't wanna spend a whole lot of time because you guys can't use the material, but I want you to see that. So when we're looking at, actually, I'll just take off the top row. Can you clear me a little bit of space? I want to set them on our mat instead of on the table. So this, I want you to look at it from your view as a square because we're not talking about it as cubes yet, but I bet you can guess that we can do this with cubing too, not just squaring. It's really cool when we start talking about the trinomial cube as a cube. Okay, so here is, I'm trying to get away from this. There's reflections everywhere. Okay, there's a nice spot. Ish, I don't know. Okay, there's reflections everywhere. So when you build this, when you build the cube, you've probably noticed that some of the shapes repeat the pattern. And so you can see that this piece is a square and these two are the exact same rectangle. And then this is a square and these are the same rectangle and these are the same rectangle and that's a square. And so that's really cool. I love seeing the connections between the different materials because maybe you've spent a lot of time building and constructing the trinomial cube. And now you can see more about how the trinomial is related because of this work. Okay, so we are going to, I'm going to show you how to record this follow-up in your journal. Now you can slide it away. Okay, so we've done lots of squaring or transforming a square. We've transformed into a binomial. We've transformed into trinomials. We've transformed other squares. We've transformed binomials algebraically. And now we're doing trinomials algebraically. So I'm going to do a 10 square because they're the easiest ones to see, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What are you giggling about?
How focused your face is.
I was counting. Okay, so now I'm going to transform it into a trinomial. It doesn't matter if you do it exactly the way we did it there or if we do it differently. I'm going to do 2 different ones. I'm going to do it the way we just practiced together. And then label the parts. This one here, oh, A equals 5, B equals 3, and C equals 2. So this one here was our 5 square. We're going to call it A squared. And this one here was A times B, AB, which is 5 times 3. And here we have, I called it 5 times 3. I should be consistent. I always tell you to count the bottom first. So this would be 3 times 5. But we know when we substitute it, it becomes AB. Let me make my handwriting bigger so you can see it. Oh, you might have been watching that the whole time. It's hard for me to know what you see when I pin it. Okay. 2 times 5. We're going to call that AC. Here we have 5 times 3, which is AB. 3 times 3 is B squared. 2 times 3 is CB, or we would say BC. 1, 2, 3, 4, 5. This is 5 times 2, or AC. 1, 2, 3 times 2 would be BC, and we're left with C squared. I'm going to write my equation over here so we take up a little less room. We have 5 squared plus 2 times 3 times 5, these two, plus 2 times 2 times 5. That's those two. Plus b squared plus 2 times 3. Oh my goodness, I'm running out of room. Plus 2 squared. Holy mackerel, barely fit on there. Okay, so to solve this or to record it algebraically, we would have a squared plus 2ab plus 2ac plus b squared plus 2bc plus c squared. There it is.
I think it fit better
without the parentheses. Well, up here I had parentheses and the multiplication symbols. Algebraically is easier to write once you get used to substituting all the letters. Okay, so in this case, I have 10 squared is equal to
5
plus
b
3. Oh, sorry, I didn't write that one in there. Plus 2 squared.
You didn't put the 2 in the c.
The 10 square is equal to the 5 square, or the 5 plus 3 plus 2 square. And algebraically, this looked like 10 square was equal to a plus b plus, I had an extra parenthesis, plus c squared. You don't have to write the second one because we already know what those are, a, b, and c right here. That'd be like substituting a, b, and c. Okay, for your follow-up, I would like you to do some 2 or more of these. You can transform whatever square you would like. The 10 is easy because there's enough things to work with. You can't really transform the smaller squares into trinomials easily because you'll just end up with a bunch of really tiny squares. So I wouldn't do this with anything less than maybe the 7. You can always go bigger than the 10 if you would like. Okay, I can't wait to see your follow-up, and we'll see you next time.